Hello, hello. I'm Cody. I'm the head of developer and product support at Fedi. And we're running the AI for All hackathon, a remote hackathon over Replit at the intersection of Bitcoin and AI. And so, how do we wrap AI with Bitcoin micropayments? How do we inject AI into various aspects of Bitcoin? So, it's all very exciting stuff. And we've got a bunch of prizes and stuff. It'll be running the entire month of July, and we'll be doing workshops all through Replit. And love if you would take part in it. So, I made this tutorial just to kind of go over really basic implementation of how you might wrap a AI call with a Lightning micropayment, right? And so this is a super simple Flask app, which I just made that for as like a hacker checklist. So it's like stuff you need to do once you join the hackathon. And so you can like join the Discord, you can register for the hackathon, you can claim your hacker perks. And so we'll be announcing a bunch of those later on this week and next week for API keys that you'll get access to. You'll be able to be able to run nodes and get claim credits and stuff for different AI and API and Bitcoin services as part of the hackathon. And then I wanted to add this button here that just lets Replit know that you want to swap cycles to Bitcoin, right? So Replit has their internal cycles accounting system, and they have a cycles API which they've been working on for a little bit. And if they ship that, then we'll be able to do stuff like swap Bitcoin into cycles. And I think it would be very cool and make paying for AI services much easier. And so when you hit this button, this is going to detect whether or not your browser supports doing Bitcoin payments. And if it doesn't support doing Bitcoin payments, then it's only going to do a GPT 3.5 call because that's cheaper. And I'm giving it to you for free against my OpenAI token. And so I'm okay eating this cost because it's really not that much, right? So it's like 0.00015 per 1,000 tokens. And it's just generating a tweet. But if you wanted to do a micropayment to me so that you can use my OpenAI key to do a GPT-4 call, well, I can't just support doing GPT-4 calls randomly for people. I need to pass this cost along to you. And so when you hit the back end, then it's going to say, oh, this guy supports doing micropayments. I'll offer GPT-4 if he's willing to pay the cost of the GPT-4 call to do this tweet, right? And so when I'm running inside the REPL, it doesn't have access to something called window.webln, right? Because this is an iframe right here. And so the way that, let me close this out. So the way that a Bitcoin wallet like Alby is going to get access to your can kind of see that Lightning invoices are showing up in your browser and be able to interact with them and pay them and like get paid and those kinds of things, is that you have to go to something like Alby, which is a Bitcoin Lightning wallet extension. And so you can go to getalby.com and you just add the browser extension, and it'll be right here. You can unlock it, which is Alby. And then you'll have a Lightning wallet attached to the browser. And when you're running this web view, this is just an iframe, and so it can't see stuff going on the window. And so on the window, the way that Alby is going to detect Lightning invoices is going to use something called window.webln, right? And so if we go over here, webln, like web Lightning, it's just a object on the browser window that you can interact with in order to do Bitcoin payments, right? And so this is going to be something that if this is present, then I know that they have a Bitcoin extension and they're able to do Lightning payments. And so I can offer them, hey, you can get the premium service if you'll do the micropayment, right? But within this iframe over here, you can't do that. And so when I do the call like this, it's just going to do the normal GPT 3.5 call, and then it's going to kick me off to Twitter to go do the payment. And so, sorry, you can't leave the iframe when you did this. But if I go click this tweet, there we go. Then it's like generated a tweet for me. about how excited it is for the hackathon and asking Replit if they would ship their Cycles invoicing API. So then we could swap Cycles with Bitcoin, right? And so that was with GPT 3.5. I can't just open up and allow people to use GPT-4 because it's too expensive. And so what I can do is I can wrap it with a micropayment, right? And so this is going to be a little walkthrough of how you would do that. And the way we're going to do that is using the L402 specification. And so what does that mean? Well, if we go look at the Mozilla status codes, right? You can see you've probably gotten this before. You've gotten bad request, right? I'm recording, right? Yes. You've gotten bad requests before. It's like, I tried to find something and the request wasn't correct. And maybe I got a 404 before, and a 404 not found in case of the server can't find the thing that you're asking for, right? There's actually a status code called 402 payment required. And this is called an experimental status code. And the reason why is because when they were originally making the web, they knew that they wanted to be able to do micropayments, but they could never figure out how. The reason why was because they hadn't solved the double spend problem. And so once Satoshi solved the double spend problem and Lightning made it so you could do instant Bitcoin payments, well, now the 402 payment required error actually becomes very useful. And so what we're going to do is when someone who's able to do Bitcoin payments hits my endpoint, then I'm going to return a 402 payment required along with an invoice. They're going to pay that invoice and then hit the endpoint again with the proof of payment. And then I'll allow them to use GPT-4 because they paid for the use of GPT-4, right? So let's go over here. What does that actually look like in practice, right? So kind of working our way along through the tutorial. Why do we need micropayments? Is that the solution for the problem of AI calls being expensive, especially when you use GPT-4 and stuff like it, is that you need to be able to pass the cost along to the user. And with a Lightning payment, you can do it instantly. So at the time that you're actually using GPT-4, you are getting paid exactly as much as you need for it. You can do it via micropayment. And so if you're not doing GPT-4, I could pass along even something as small as like a GPT 3.5 call, right? And because micropayments on Lightning, you can get down to very, very, very small amounts. You can get it to sub-cents, right? And Lightning is a bearer instrument, and this is going to be a huge issue. So when you guys are building AI applications and you start charging for them, a huge issue that everybody's running into is chargebacks. And if you're using credit cards, fraud within AI is enormous, right? And you don't want to have to be on the hook for somebody doing like $20,000 worth of expenses, and then 20 days later, they come back with a chargeback. So Lightning payments are a bearer instrument. The moment you get paid, that is your money. It can't be taken from you, right? So what does that look like? So we start with a really basic Flask app, right? And so I've split it up a little bit, but this was just built off of like the Flask Replit template. And so we go to like our main.py. Let me do a quick little walkthrough here. Is that we just have like a simple database that we use for tracking user IDs. We have like an OpenAI key that we set, a macaron secret key, and this is for when we do a token on the user sessions, and when we do tokens for the invoice commitments that we're going to do. We'll get to those later. We just need a secret key, and so those are set as environment variables. Then we also need a Lightning address, and this is going to be the standard that we use for interacting to get a invoice, right? And so if you've installed Alby normally gives you a Lightning address, and this Lightning address is just a way to, over HTTP requests, get Bitcoin Lightning invoices that can pay you, right? And so we'll get into those specifics, but like just when you sign up for Alby, or you can sign up for Zebedee, or you can do Voltage, or just any of the services where they have a Lightning address server in front of the Lightning node, we're going to use the HTTP request just so we don't have to get into like the details of Lightning implementations, right? And then we've got two routes here. We've just got the home route, which I still haven't changed from Hello World, right? Because which attaches a user ID with a session. When we go over here, right? And then we have this GPT tweet, right? And so when the user hits that button, then that hits my backend, because I don't want to have my server, I don't want to have my API keys exposed on the client side. The API keys are all on the server side. Is that they hit this GPT tweet, and the base assumption for it is going to be that it uses GPT 3.5, right? And then we go down here, And what we're going to do is we're going to check if the user has WebLN enabled. And so what does that mean? Is that for Bitcoin wallets, the way that they interact with the web is via this object called WebLN. And this is open from when I was starting this recording before, and I was doing this, right? But so if that's present, then the client that sent me this is able to interact with the Bitcoin network. And so I can send them back an invoice and they'd be able to pay it, right? And so it sends back the, if WebLN is enabled, then it goes into the WebLN auth flow. So the first thing it's going to look for is this authorization header. And so this is going to be that if I sent you back an invoice and you paid it, and then you gave it back to me, you're going to put that proof of payment inside the authorization header. So I validate the L402 authorization header. And if it's valid, well, then that means that you paid me for it. And so I'm going to let you use GPT-4. But if not, well, I know that you're able to support micropayments. And so I will get a invoice for a certain number of sats. Like for me, just like for you to use GPT-4 to generate a tweet, that's going to cost me like 3 cents for every time that you do it. And so this is just an invoice for like 4 cents, right? So I get the invoice for that. And then I get to do some stuff down here. We're going to get into this later. And then I pass that back as a 402 status code, right? And so if I go over here and I go look at my console, I can go like this. And I can go look at the network tab, how that worked. And so when I went here, the first thing I did was this post. And then I got this back. Sorry, I'm gonna log this just so you guys can see it easier, because it's much more intuitive. And so if I just go into the index.html, just go down to the JavaScript, and then I just want to console log these. Let's just console log the whole header to get it. It's here. Console log auth header. I am console logging the auth header. So why is this not showing up? There we go. Cool. So here we go. So we got this auth header back, and the auth header contained a macaroon and an invoice, right? And so this is the thing that I was talking about before, where I pass back the invoice, and the invoice here is the Lightning payment, right? And so if we look in the code, this is when it gets that. Sorry, when it gets that on the index.html, which is over here, get rid of that. If it gets the 402, then it pulls off this authenticate, and it gets a macaroon and an invoice by decoding the auth header, right? And so what are those two? Well, we can learn about that as we continue on, right? Why is that doing that? Okay, we went over 402s. We went over this. Okay, yeah, so basically here's what the interaction looks like, is that the client tries to hit the protected server endpoint. The server replies with a 402 payment required, the Lightning invoice to pay, and a token committing to the original requested invoice, which we'll get into. And the client pays the invoice and hits the server again with the same request, the token, and the proof of payment, right? So what I just went over here was when I hit the button, it detected that I had WebLN enabled, and it passed back a 402 error to this post request that I did. On that 402, there was an authentication header. An authentication header contained two things. It contained an invoice and it contained a macaroon. And so I stripped off the invoice on the client side and passed it to Alby. I passed it to WebLN, which for me is Alby. And so here you can see me doing that, where I say, I'm verifying that WebLN is defined. And so then I do window.webln.enable. So turn on WebLN, pass it a command that it should send a payment, and then wait for the pre-image, which is the proof that it's been paid, right? So if I go here and I hit pay now, that just did the payment, and then it passed back the pre-image. And so if it gets the pre-image, I've also got it logging here. So you should be able to see those right here. Yeah, so it got the pre-image right there. And then what it does is it attaches the pre-image to the macaroon. And so we can go into the implementation of details of that, but basically the macaroon is a commitment to that specific invoice. And so when I provide both the pre-image and the macaroon, when I return back to the server, what I'm doing is I'm showing, hey, that invoice that you gave me, the specific one that you did for that same request that I'm sending right now, I paid that one, and here's the proof, right? So I finished the micropayment, so give me access to the premium service. Okay, so that's the way that it works. And I've copied the L402 protocol specification into here as well. Cool. So returning the 402 error, right? So that's going to be in here. So what we did for GPT tweet is that this receives a post request, and then it does like the initial configurations for it. And the first thing I did was I just passed this in just to make it easier. So I didn't have to do a round trip of like, oh, ask is WebLN enabled. I just have the client say whether or not it does WebLN. And if the client does do WebLN, well, then I will generate an auth header. I'll check the auth header. And if the auth header contains a proof of payment and a specific macaroon for that this server signed, well, then I know that this is valid and I should give it access to the resource that it purchased, right? So that goes, it validates the 402, it sets the model to GPT-4. Otherwise, it gets the invoice, so it gets the invoice for that amount. It gets the payment hash off out of the invoice. And so if we go look at what a Lightning invoice actually looks like by decoding it. So I go to decoder. We can see in here, it actually contains a ton of information. One of the things that it contains is this payment hash. And so the actual proof of payment of this specific invoice is that when you complete the payment, you will get a pre-image. And the pre-image, I should be able to put that into SHA-256, the hashing algorithm, and get the proof of the payment hash that was in this specific invoice, right? And so what I'm doing here on the server side in main.py is I'm pulling off that payment hash, and I'm generating a macaroon committing to this payment hash, right? So now when I send this back to the client has to return both the macaroon and the pre-image. And so inside the macaroon is the payment hash. And so I can do the check that is this pre-image when hashed equal to the payment hash inside of the macaroon that I sent. And a macaroon is just like a fancy token, right? You can do like all sorts of fancy things on it. You can also use JSON web tokens for this protocol, but just macaroon is just a fancy way to do it. And it's it's really useful because with macaroons, you can do additional caveats and that kind of thing. So then we pass that back, the 402 status code, along with the header www authenticate. And so that's L402 macaroon equals macaroon. And you have to add this colon right here, which is the separation between the macaroon and the pre-image eventually. And I think that we should get rid of that, but that's part of the specification right now. And then we also have invoice equals invoice, right? And so this is the invoice that we're passing back along with the macaroon. And that looks like this return that we have over here. Okay, cool. So back to the tutorial. So we do that. We implement the 402 error handling, which is right here, which we just walked through. And I added this, does the client support WebLN, like passing that in the initial request. Normally that doesn't happen. And so you should just pass back, you should just have like a specific endpoint that's gated in this way, right? But it's very useful if you have that, because then you don't have to do another round trip, right? So that's like a way to get around it. And so here, this is like the return logic. So like if WebLN enabled is true, then get the auth header. If the auth header is there and it's valid, well, then use GPT-4. else return early with the 402 error. But if they don't support WebLN, well, then just go use the tweet using, just go do the tweet using GPT 3.5, right? Because they can't pay you for the GPT-4. Cool. So now we're going to decide on Lightning invoices, right? And the way that we're going to be doing the Lightning invoices here is using Lightning addresses. And that's just something, it looks like a email address, and it makes it a really user-friendly way to interact with Lightning nodes, right? Because you don't actually have to speak Lightning to it. The Lightning node is running an HTTP server in front of it. So you're just doing HTTP calls against that server, and then it on the back end is getting invoices, checking they're paid, all those kinds of things. You're just doing get and post requests, right? Just super nice. And so how do Lightning addresses work? So when you install the Alby, you can set up a Lightning address. And the way that it works is you've got username at domain.com, right? Or domain.net or whatever it is. So what you do is you parse that, and then you do send a get request to domain.com/ it should be .wellknown. Sorry about that. I can change that right now. Invoices. .wellknown. What's that too? Yeah, this workspace a little bit. Getting the Lightning invoice. Okay, so I should be able to hit against a and I should be able to hit against this endpoint. So if you're like Bob at getalby.com, then I should be able to hit against https://getalby.com/.well-known/username. Maybe there's someone called username who uses getalby. Sorry, that's curl. Curl. Okay, yeah, there's nobody named a username. That'd actually be a good one to take. So I think I'm gonna take that before I launch this video and somebody else takes it. But I can do it against mine, right? So my address is Cody. My Lightning address is codylow at getalby.com. Well, that's like one of them that I use. And so I'll be able to go to getalby.com/.wellknown/lnurlp/codylow. Right? Oh, oops. All right. I didn't have an lnurlp there. That's probably, there probably is a username. Nope. There we go. Cool. And so when I hit that, I get this big JSON blog response. And so I don't feel like parsing that right now. And so I'm just going to take this same thing, just hit against it in a different tab so you can see it. So over here, I hit against getalby.com/.wellknown/lnurlp/codylow. And so that's like the first call that I do as part of the LN address, Lightning address spec. And that returns this big JSON blob back. And so there's a couple of pieces in here that we need and a couple that we don't. The important thing that we need is this callback, right? And so this first call that I did was basically get me the data about this Lightning address. Like, is it valid? Does it accept payments? What's the min payment? What's the max payment? That sort of thing. This callback is if I want to get an invoice specifically, where do I go? And so this could be anywhere else, but the Lightning address server just says, this is when you want to get an invoice from Cody, go use this endpoint specifically, right? So I hit that. When I get that, I get an error. And so this was something that I didn't realize, is that a lot of Lightning addresses do not support amountless invoices, right? And so that's something where you actually have to set the amount. And so you're going to set that as a query parameter. You just do question mark amount equals something greater than the minimum, right? So the minimum here was 1,000. And these are millisatoshis, right? So this is 1,000 would be 1 Satoshi. So if I hit that, well, then I get this back. And so I get this verify URL, which is something that the client can poll against in order to see whether or not the invoice has been paid, right? And so that's like a useful client side thing for while you're doing that. we're not going to use this. Like we're just going to have this all be server side and just using WebLN. And this PR is a payment request, and this is what the actual invoice is, right? And so if we go over here, where is this actually implemented in code? So that when I go to here, I get an invoice by hitting the Lightning callback, which we set up here. Remember we said, hey, you have to put your Lightning address, and then it calls get LN callback. And then that does the split and the switch. And then it tries to get the res there. It gets the res there, and then it tries to hit against the it tries to parse it out and see whether or not there was a callback returned. And if there was, then that's a valid Lightning address, and I can go hit against that, right? And so that's the LN callback right there. So I hit that in order to get the invoice, and then now I have a Lightning invoice, right? And so I can take the Lightning invoice and I can send that back to the user. But the problem is that if I just send the invoice back to the user, how do I know that after they pay the invoice, they didn't change the body of the request that they did, right? And so maybe they, maybe I hit them, sorry, they hit me first and they were like, hey, I want to do a call with GPT-4 and I only have a 2-sentence prompt, right? I would give them an invoice for maybe like 1 cent or something. And then they pay that invoice and then they come back and they say, okay, I paid your invoice. Here's my prompt, but they've swapped out the prompt and now it's like a 4,000 token prompt, right? Well, that's a much more expensive call for me, and that's not what they paid for. And so what we do is we pull out the payment hash and we pass the payment hash into the macaroon. So when we generate the macaroon, what we're doing is we're saying, hey, this is where the macaroons came from. Here's an identifier for it. We use this secret key. So this is like initially creates the macaroon. And then we make a caveat to the macaroon, which says, hey, the payment hash has to equal this payment hash, right? The thing that we're committing to that we passed in when we're making the macaroon. So when I pass back the invoice and the macaroon contains a commitment to the invoice. And so in order for that macaroon to eventually get satisfied, they have to pay that invoice specifically, right? And so if I were also passing in like a body, like currently I'm not doing that just because I'm generating the prompts on the server side. I'm not asking them for the prompt like I would during a chat app. During a chat app, I would also have this be like, like body, like request or something, right? And I would take a hash of the original request that they sent, and then I would guarantee, and then I would request, and then when they did the payment, then I would verify that, hey, this is the same body that they sent the last time, right? So that's just a tip for that one. Okay. Cool. Let's go back to the tutorial. Over here, that gives us everything. We implement this stuff, and this is how we get those. Yeah. Cool. So this is how we get the invoice. So once we get the invoice, then we do to get the PR, so the payment hash, so to get the P tag out of the invoice, the payment hash. I'm using this Bolt 11 library that LN Bits made. Make sure that when you're pip installing this, you actually use the one on GitHub. You don't use the one in the pip registry just because that one's out of date. And so it won't work if you try to do that. So just use this one. So what we do here is we do bolt11.decode invoice and we get the P tag, right? The P tag is the payment hash. And so that's that payment hash. Then we take that, pass it into generate macaroon, which I just showed you. And then I just created this one so I could log it. And then we put it in the authenticate header, right? So remember what we said for the L402 specification is that you hit it first, and then you hit the server first, and the server replies back with www-authenticate L402 macaroon equals macaroon, this full colon here, and invoice equals invoice, right? Cool. So now the client side code. Okay, so we've gotten to over here where the client has received this. There's this macaroon and there's this invoice. Well, the client side code is relatively straightforward. Is that if the response status is a 402, well then it pulls off the authenticate header, and I'm just having it log it. It parses out the macaroon and the invoice. It formats the invoice so that it strips off the quotation marks. And then it says, hey, if window WebLN is available, so that means there's a Bitcoin wallet attached to this browser, then turn it on and ask it to send a payment. Once it sends a payment, you'll get a pre-image. The pre-image is the proof of payment. And the pre-image is the thing that when hashed is going to equal that payment hash that we committed to. And so here it just does some logging, but then it creates the auth header, which is L402 macaroon is equal to the original macaroon that we have there. Sorry, to the macaroon that we have here. And the macaroon here is the original macaroon with a full colon that we pass back plus the pre-image, right? So like macaroon equals macaroon colon pre-image, right? So then we go here, we send the response. And so this is just sending the exact same thing. This is just retry logic because this is all inside. So see, I did this GPT tweet, right? And then I do the same thing again, but this time I attach the auth header to it with the macaroon and the proof of payment. So the final part of this is on the server side. And on the server side, like we said before, in NumPy over here, is that the first check that we do is that, hey, is there an auth header already on, we got get WebLN enabled. If there's an auth header, then we have to validate the auth header. And if the auth header is valid, then they get to use the premium service, which is GPT-4. And so the way that we do that is this valid L402 auth, right? So first off, we check that the formatting is correct. So it's like L402 is in the auth header. We split out the parts. The parts should be equal to 2. And this colon, right, should be there. So that's like, hey, there's a colon here. And then I split on colon. And so now I have macaroon and I have pre-image. And so I have to strip off this macaroon one. This was very fast implementation. This was like not the cleanest way of doing this, but basically I need to pull out what the actual macaroon is. I have to pull out what the pre-image is. Then I go decode the macaroon, put the in this decode macaroon, this is where I check that the payment hash is inside of there, right? So then once I get the payment hash, well, then what I can do is I can do the check for if the I can do the check for the if the pre-image hashes correctly to the payment hash, right? So I do a check here, and then I can actually get rid of this one because I could implement this differently, but you have to define the caveat verifier. And so when I do the macaroon verification using the PyMacaroons library, you have to have a verify function. And so the satisfy general is like this first party caveat that I put on there that the payment hash should be equal to this hash of the pre-image, right? And so then it returns valid macaroon or macaroon was tampered with, or not all caveats were met. And so, yeah, that's like the whole implementation, right? So it's the whole handshake. So if the macaroon is valid, then it just continues down the GPT-4 path, right? And so let's go look what that actually looks like. So I go here, and actually stop this because the formatting looks nicer when I do it this way. So I hit this button, I get the 402 back, I do the payment. Okay, I think that was a little bit too delayed, but so if I hit this, then I'll open up the new one. So it logged it, but it didn't actually do it here. I'll probably re-implement this so that there's like a separate button for it with the Twitter button with the Twitter intent there. But yeah, so this one was generated with GPT-4. And so it says like super pumped for the AI for all hackathon. Can't wait to flex my Bitcoin coding skills at Replit. How about enabling cycles Bitcoin swaps? It'd be amazing to apply our skill across the web universe. Build on Bitcoin. Check it out, folks. There we go. Isn't that exciting? Cool. Yeah, so this is like a pretty fun project for someone to get started with doing 402 payments in the browser. So that's all. Thanks.